I told you that I wouldn't make these videos all the time, but I would make them when something key was in there or something that I think the book didn't do a great job on, and I wanted to clear it up. So I'm going to clear up something today, but also mention something very key. First off, there is a word, or actually a phrase, in your book that they seem to give legitimacy to, and I don't particularly love it. It's the phrase human error, okay? Really bad. The reason I don't like it is because people tend to say, well, the the experiment had some issues with it because of human error. Well, that's such a catch-all that it basically means nothing. What did the human do that was incorrect? That's really what you want to get into when you're talking about error, not human error, right? If human error is the reason for the issues or the inaccuracy of your measurement, then the real solution to that, the only solution I can think of, is to get rid of the human, namely you. And obviously I don't want to do that. So let's not say human error. Let's keep that out of our vocabulary, basically. The most important concept in this reading is very clear. I think it's under significant figures, the heading significant figures. If you go to one of the sentences just below that, it says, there is always some uncertainty in the last digit reported for any measured quantity. That is a really key sentence there. Okay, again, there's always some uncertainty in the last digit reported for any measured quantity. And to make that point very clear, let me show you how we actually make measurements. And so if you look at this page that I have here on Notability, this is taken from getchemistryhelp.com, but I really like the way they set it up. They have two rulers. You have a ruler with tick marks. That's what we call them. These little lines here. Tick marks at every centimeter, and then you have another one below it with tick marks at every 1/10 of a centimeter. Okay, there's a big difference between these two things. And one of the easiest ways to tell that there's a big difference between them is usually when this is your measuring device, it's a lot more expensive than when this is your measuring device, right? If it has tick marks more often, it typically is much more expensive. With balances, if you have a balance that can give you to the 1,000th of a gram versus one that can give you to the 100th of a gram, it's usually a factor of 10 more expensive, just for instance. Anyway, what do we do when we make a measurement here? We actually allow ourselves, as it says in this little section of reading, you allow yourself one more digit. More specifically, the rule tends to be if you look at the difference between one tick mark and the next, you get to estimate 1/10 along the way between those, right? So if there's a difference of 1 centimeter, obviously there is right there, between those two, then you get to estimate 1/10 of a centimeter, right? So as it says here, you might estimate that the length of this is 2.3 or 2.4. Okay? Now, if your tick marks happen to be much more closely, held, as in this one, I'll zoom in a little bit, right? You've got 2.1, 2.2, 2.3, right? You've got these tick marks which are much closer. Well, now you've got, you are certain that it is somewhere between 2.3 and 2.4. Well, but when we write our measurements, we always write one uncertain digit, right? And so you're not allowed to just stop at 2.3 or 2.4 even, right? You have to say, okay, what's the uncertain digit that goes between those, right? And so you might say 2.35 or 2.34 or something like that, as it says here. I wanted to clear that up because the way the book talks about it, they're not totally clear on that last estimating digit, but it is really important when you make a measurement to know how to do